Hello, everyone. Good afternoon. Wherever you are watching from, my name is Bashir. In this video, I am presenting to you some solution to IGCSE past question. Let's dive in. The first question on the slide is to write down the order of rotational symmetry of the diagram as it is shown above on the slide, sorry. When we talk of order of rotation, is the number of times a shape fits exactly onto itself during a full turn of 360, that is one revolution. In a simple term, we can also define it as how many times a shape looks the same as it rotated one complete turn, which is as it rotated under 360. To digress further for better understanding of this order of rotational symmetry, let me just illustrate like this. Let's assume we have a shape, a square shape. Let's, for example, we have a square shape of this. This is a square shape. And in this square shape, let me have another shape to see okay. Let's assume I have another shape, maybe directional shape. Let's say this one. Let's just put it here. And let's change the color of this shape to red. Let's fill the color to red. Okay. Okay, let me fill the color to red. Let me take it inside the shape so that it will be better. Let's take it outside here. And let's merge the shape together. Let's group it as one shape. For example, if I rotate this shape, you can see the arrowhead. Let's assume I rotate this shape and go 90 degree like this. It will still assume the shape of a square. If I rotate it another 90 degree, make it 180, it will assume the shape of a square like this. If I rotate it another 90 degree, which make it 270, it will still show the same of a shape, which is still match as a shape of a square. Then if I rotate the last back to its original position, then it will rotate, it will come back to its original position, and it will still assume the shape of a square. That means I turn this shape 4 times, and each time I turn it at angle 90 degree, it will match to the what? To the shape of a square, for example. That means to say that if I draw it this shape, because it is similar to this shape, once I rotate it, anytime I rotate it angle 90 degree, it will what? It will assume the same of a shape of a square. So that's say that we can write that I can write that the order of rotation, the order of rotational symmetry n is equals to 360 times over the angle of match. Angle of match. What I mean about angle of match is that the angle I rotate this shape and to have the same match as a square. Right? So now we can define that order of rotation as, let's say the order of rotation now will be 360 divided by 90, because each time I rotate it 90 degree, I will still have the same square of the same arch of a square. So with this one I have 4. So that is a simple analogy of what? Of symmetric, rotational order of rotational symmetry. Now, if I also pick a square, the same thing will, let's say an equilateral triangle. An equilateral triangle that is a regular equilateral triangle. If I pick it, that all the sides are equal, and I rotate it 120 degree. If I rotate it 120 degree, let's for example, I pick equilateral triangle, for example, so I pick one equilateral triangle here. If I have this equilateral triangle, and each time I rotate it, I rotate this point to this point here, for example, let's this point now assume here. That means I rotate it at 120 degree, 120 degree. So I will assume the shape of the equilateral triangle. If I rotate it from here again to here, let's this one now come to this place. I will see what? It will still assume the same equilateral triangle, which is the same match. If I rotate it back to the what? To the initial position, it will what? At an angle of what? 120 degree, it will assume to its original position. Then with this one, we can say for triangle, we can say that for triangle, the order of rotation is 360 divided by 120, and is equals to what? It's going to be 3. That means I will rotate it 3 times under 360. So that's the simple explanation of order of rotational symmetry. But in a simple time, since you don't need to waste time on this, it has been proved that the number, if the shape is a regular shape, and if it's a regular shape like a square, equilateral triangle, pentagon, hexagon, regular pentagon, regular heptagon, octagon, nonagon, decagon, like this, if they are the same, if the sides are the same, the number of sides is going to be the what? The order of rotational symmetry. So it has been proved in that manner. So now that's order of rotation. So the order of rotation for this square now can say is what? Is 4. Now B, on the diagram, it said draw all the line of symmetry. Draw all the line of symmetry. The line of symmetry is a line that divides a shape into two equal match. So if I draw a line, the possible line of symmetry on this square here is, the first one is this. If I draw a line on this one and I close it, fold it along this line, this shape will give me what? Will give me the same match. If I also draw it, the line of symmetry, along this line, this at the middle, I have another line of symmetry, which is equal match. I can also draw it diagonally, can also divide it diagonally like this, and I fold it along diagonally like this, and I fold it this way. I will still have equal match. If I do it the other diagonal, the other leading diagonal, I will still have the same match. So in this, we have four possible line of symmetry for this. Now, number two says that the probability that a train is late is 0.5. The probability that a train is late is, if the probability that a train is late is 0.15, probability a train is late is equals to 0.15. The probability the train is not late will be equals to 1 minus the probability the train is late. Right? It's one of the property of probability that say that the probability that an event has taken place, if it is X, the probability that that event will not take place is going to be 1 minus the probability that has taken place. So this is going to be 1 minus 0.15, and the answer to this one will be 0.85. Now, the third question here is this, that the stem and leaf diagram show the number of hours that each of 16 students study last week. So the data we have here is 16 data. How do we extract the data from the stem and leaf diagram? The stem and leaf diagram is a tabular form of presenting data. So we can extract our data from stem and leaf as follow. This is combined with this one. I have 1, 2. Then this with this, I have 15, 1, 6, then 1, 8, then I have 2, 0, 2, 1, 2, 1, 2, 7, 2, 7, 2, 9, 3, 2, then 3, 3, like this, 3, 3, 3, 4, then we have 3, 5, We have 4, 4. Then say 4, 5. Then 4, 7. Make it 16 data that we have. Now, if we are to calculate, the median of this, the median is a number that falls at the middle after the data has been arranged in ascending order. Now, the data already is in ascending order. Then the medians the median position will be equals to n over 2. So which is, we have 16 data there, that's 16, n is 16. Will give us 8 position. I mean the position when we count data where we get it. Then when you count it from the beginning, 1, 2, 3, 4, 5, 6, 7, 8. So this is the first. Then let's count it from the back. 1, 2, 3, 4, 5, 6, 7, 8. So we have 2 central value that enter this. So now if you have this, so we can now take the average of the 2 value. So the median will now be the average of the 2, 27 plus 29 divided by 2, which will now give us 56 divided by 2, and the answer will be 28. So the answer to that question will be 28. Then the mode is the most occurring numbers. The most occurring numbers is the mode, and the most occurring number in this data is the 21. So these are the most occurring numbers. So answer is going to be 21. Then the range is defined as the highest data minus lowest data. The highest data minus lowest data is the range, and the highest data here is 47, while the lowest data is 12. We subtract it, then 35. So the range is 35. Next question is this. Next question is angle between line. Under angle between line, we have this diagram. Where so the angle here must be equal to angle here. So and this angle here must be equal to angle. This work at the principle of vertically opposite angles are equal. So vertically opposite angles are equal. So it means that A is equal to